Ahoy! Today is going to be a repair video, but a bit different. Some of it will be in story form, since I'm not working on this alone. And I don't know if I actually managed to fix something, but we get an interesting story out of it. A story that begins with one of my friends trying to do his laundry and the machine outright refuses to start. If I understood correctly, when trying to start the machine, all that happens is the screen shows up, the lock icon flickers, but it never actually starts spinning. Or the machine is this, it's an AEG, L8 blah blah blah, but actually it's made by Electrolux, and Electrolux has another model number for it. So my friend went and found this service manual for an Electrolux something or other, which I'm not 100% sure it's the correct service manual, but it looks right, and later we will see this is close enough. The service manual has some instructions how to do a self-test on the machine, and the result of doing a self-test is this. So what we do is we go to the service manual and we go to the alarm summary table, and then a few pages onwards we will find E6A, and these errors are pretty much the same across all Electrolux machines, so even if we have the wrong service manual, it's no big deal. And it says heating relay sensing failure. Wrong input signal to microprocessor, mainboard defective, and cycle blocked with door locked. I believe that matches the symptoms, but I wasn't there to see it. And to reset this, you have to press the reset key. They have different keys to reset different errors. Why? I don't understand. That seems like madness, but it is no different. I'm not exactly sure what they meant by heating relay sensing. Anyway, they told us the main board is defective. But before that, just for sanity check, I told my friend to measure the resistance of the heater, and it's about normal, so there's that. So, mainboard defective. So I told them bring me the mainboard, this is that. And the heating relay has got to be one of these. So I tested all the relays. Looks like 3 of the contacts are marked with the common, normally closed, and then normally open, I guess, but it says NA, so maybe it's normally open. And there's then 2 more for the coil. So I just put the voltage on there and I cranked it up until I hear click, and I checked the voltage, I checked the resistance, and all of these relays are just happy, so it's not the relay itself. And then I spent quite some time squinting at this and poking at this. Of course, first thing I wanted to figure out is which one is the heating relay, this one. And I figured that out by finding this connector goes to the heater, and the service manual tells us that. And then following the traces that go to that connector to that relay, so it becomes obvious. And yeah, I figured out, like, since it's not the relay itself, I don't know, maybe it's the transistor that switches it. So I followed also the coil contacts, and they go to one of these tiny transistors, and all of them appear to be like bipolar transistors, which you can check sort of if they're working, like by putting the meter to diode mode, and then you go between one pin and the other, and there's gonna be like, it's gonna act like 2 diodes in a certain configuration. And like, I don't even look up the pinout, I just take a look if I can find like 2 pins that act like a diode, give me a voltage drop about 0.6 volt. If it does that, it's probably okay. Most of the time transistors, they just fail short circuit, so I figured the transistor driving it is gonna be okay. I don't actually know which one it is, but I figured that out at the time being by following the connections from these two, I believe. Also, well, in this meter you got diode and continuity check in one, so you can just poke one of them, and then if you can see it very well, but then usually they bugger off to a via. I don't know if they're like, yeah, so this one just goes straight to a via under the relay, so yeah, I believe it goes there. Yeah, this is not the heater relay, but you can see one of the coil connections goes from there up to that tiny transistor over there. I don't know how visible that's going to come out in the video, but just believe me, there's a trace right there from the via. You can see just sticking out from under the relay. Anyway, I done the same for this one. Forgot where the transistor is, but presumably that is not the problem, unless the transistor failed in a strange way that we cannot just figure out by diode test, but usually they either fail totally open circuit, or more likely they fail as a short circuit. The next thing is probably the more sensible thing, which of course I saved for last, also because it's kinda more work, and that is figure out what the heck with the sensing thing. What the heck do they mean? So, blah, blah, blah. Where is that relay? It's this one. So, the normally closed contact of that, if I remember. Wait, yeah, no. I did follow this one, but that's the wrong relay even. This normally closed contact goes buggers off somewhere. But yeah, this one goes some places, but it doesn't really go anywhere interesting. There's no connection that I could find that goes anywhere towards the microcontroller, which the service manual was suggesting. There's some kind of sensing done by the microcontroller, so the normally closed connection doesn't go somewhere that interesting. But then this one, you can hardly see it, but there's a via over there. Now follow that. That goes to in between there, and then with the continuity test and also resistance mode. Sometimes continuity test can like kind of fool you because it will beep when you have a low resistance, but actually it isn't a direct connection, and sometimes you want to follow through where the resistors go. Anyway, comes out there in the middle between that resistor right of my finger and that diode right of my finger, and you can kind of see here these three resistors are all connected in one line. They bugger off somewhere here and they go to one of these pins, which is, this is where the mains comes in from the wall, which is, first of all, it's heavily implied but not directly said in the service manual. They just show like some cord buggering off to nowhere, but also we can see there's like a common mode choke and then a bunch of capacitors to filter, and then yeah, there's a rectifier and goes to a 400 volt capacitor, and there's more power supply stuff. Anyway, there's that. So and then the other side also goes around through these resistors. The resistors on the left side of that via I was talking about, that comes straight from the pin that's being switched by the relay. The other pin of the heater, it just goes to one of these, and this connector, as the service manual tells me, is the door interlock. So this has a switch between the two rightmost pins that closes when the door is closed. Anyway, I followed this further, and one thing, pro tip, if shit gets confusing and you have a lot of little shit like this, you can use a Sharpie and just mark things. So I found where this goes. There's a few resistors and one more over here, so there's that. I also made some marks here. Anyway, all of that, I was just following where does this go, and what actually happens to the signal or whatever. Where is it connected? Anyway, I followed it this far, and I figured it connects to nowhere else interesting than this one pin on the microcontroller, so I suppose that is where it does the sensing. And the next thing, didn't really know where to go from there, because everything seemed okay. I measured all the diodes and stuff on the way. There's a diode here, but also here there's a diode that goes somewhere, and it's in parallel with a resistor and a capacitor, and since they are bringing an AC voltage to that microcontroller, I suppose they're like rectifying it, and that explains why there are diodes. Anyway, I checked those on diode check mode, and they do the diode thing. They're not short circuited, so they work. Honestly, this kind of parts, they're in this situation, these are not things that are under heavy stress. They're not something I'd expect to fail, but yeah, anyway. What the hell could be wrong with this? I totally expect just the relay to have failed, or contacts to be dirty from moisture. One thing I would possibly expect to see in a board like this from a washing machine is that maybe one of the vias would corrode and no longer make a connection, but that's why also I check on the ohm setting, but no such problems to be found. Anyway, I figured I'll have a look and like just connect mains in here, and then I can put mains on this pin that goes to whatever this sensing stuff is supposed to be. I really don't understand why they even have this. Like, it's not making the machine more reliable, because this fails, the relay is just happy. If they didn't try and sense it, it wouldn't break in the first place. But yeah, maybe it's something like to do with ensuring that your clothes don't catch fire or something. That's the only plausible explanation I see. Anyway, if I want to measure this pin also, of course I needed to know what is the ground, and often you get really lucky and you can just like, you know, find the nearest big capacitor, and then the negative side of that is ground. But these two capacitors, they are in series. the positive of one of them goes to live or neutral. I forgot. Well, I actually don't know which one is live or neutral, but it doesn't matter, it's AC. Anyway, it wasn't so trivial in this case, so I had to find the data sheet of this STM8 something something, and the 5th pin down from here is ground, so I found some easy place where I could access it, which is these 2 small decoupling capacitors, and I soldered me a wire over here for the ground, and then a wire here to intercept whatever signal is coming from that sense thing. I checked what's happening, and it didn't seem sensible. Like, we got either 1 volt if it's connected, and then 0 volts when it's disconnected. 1 volt seems ridiculous. You'd want it to be about at the power rail of this thing. And on the other side of that resistor I also measured that, but I'm not gonna repeat this on camera, I think, because it's kind of a sketchy affair. There's mains on all these connections, and my setup is very sketchy, but I also probed over here on like some of those capacitors, and turns out this microcontroller isn't powered when you just power it on. I figured out if I bridge these 2 for the door lock, then the microcontroller is powered. At which point something changed, because the reason I was suspecting something's going to be different if this microcontroller is powered is because we got this diode and these capacitors and resistors and stuff that also hook the signal to somewhere, and this is all parallel on the other side, so I guessed that it's gonna go to either the positive rail or the ground for this microcontroller. I later also confirmed that they do. Anyway, so I figured that might matter. Also, microcontroller, they all have like built-in diodes for ESD protection of the pins, so you can see it like there's a diode to each power rail. Like, if you feed it more voltage than the VDD, then this thing will take some current from that. And the same thing if you give one of the pins a lower voltage than ground, then a current can flow in there. Anyway, with that bridged, things looked slightly different, but like on this one side of the resistor, it's like we got a change. I got a change in voltage on this one side of the resistor when I applied or did not apply voltage to this side, which I did by just bridging from this pin, the top one of these 2, to this pin, which is exactly what the heater relay would otherwise be doing, but I don't want to be faffing with that relay while this thing is powered, because you cannot touch anything or it will hurt. Anyway, but yeah, on the other side it was like 2.2 volts when something's connected, 2 something odd volts when it's not connected. Didn't make sense at all. So I spent another half an hour squinting at this, and I got out this thing and I measured the resistance of all the resistors. This is a small loop so that you can see these things. This resistor is just in series with the microcontroller. It should show by now. I made a rough drawing of what's going on. It's kind of weird, like the let's call this neutral, is connected to the positive of the low voltage power supply that goes to the microcontroller. Then this switch is the relay, and over here this junction is where the heater would connect. That would go from here then to the neutral also, and this is those 3 resistors in series at the right of that, of the via that comes straight after the connector. That's the big diode I show first, then there's other 3 resistors. This is that group of little components close to the microcontroller. Anyway, the circuit is like this, and then we have a 4.7k resistor going straight to the microcontroller. Only, of course, it's the last one that I check. It's supposed to be 4.7k, but it measures 2.47 mega ohms, so that's not right. Yeah, I cannot. Yeah, okay. It's gonna suck to show this while hand holding the camera, so screw that. You'll just have to believe me. It is measuring way high, and that ended up being the problem. And what the hell? Like, it's not like it's a power resistor, it's also not like it's dissipating any power. This is going to be like going to the microcontroller pin, and it goes there, and only there. That pin is going to be a really high impedance, not high enough to be driven by the voltage if it's like 2 mega ohms, but it's not gonna get hot, and yeah, just don't usually see resistors failing. If you do this simulator thing here, we can see how it's supposed to work. I have no idea what the capacitance of that capacitor is. It doesn't matter. Yeah, but I have this set to 230 volts, 240 volts, and then these resistor values are actually the ones that are marked on there, and they're getting like 3 volts on it, which is about right. I think the microcontroller runs at 3.3 volts. So yeah, this resistor failed for no apparent reason, but shows that it's worth sometimes squinting at stuff and checking things that you assume are like not going to fail. It's really the last thing that I checked. So yeah, the next problem was I don't have any resistor in the house that has that value, but well, I mean, I don't have a tiny SMD resistor like this. I have bigger ones, like 0805 or something, but I think these are 06 or 03, I don't know for sure, but yeah, I found this thing. It's a piece from a Fujitsu Siemens server, and it has the same size of resistors, and there's some 4.7k resistors over there, so we'll use this as a donor board. Of course, you could easily order a resistor like this, but my friend wants to do his laundry, so we're not going to wait for shipping. So since we really don't care about this old resistor, I'm just gonna blob some solder on it and hope that it sticks to the iron. And it did. Yeah, the pads are clean enough. And now we try to find our new 4.7k. I'm really not set up to film small things like this. I think I'm gonna use hot air to take one of these off. We get a few tries actually. A little bit of flux probably helps. There we go. If I actually cared about this board, I'd probably mask off whatever is not involved and maybe even preheat the board, but in this case we just want the resistor alive. There we go. Now, and back to this board. Don't lose that resistor. I'm just gonna get it out of the way first. And then one of the two pads. Ooh, my soldering tip is way too filthy for that. Okay, so I got solder on one of the pads. Then I'm gonna try to move that resistor onto there. Solder one side, and then solder the other, and then go the other side again. Okay. Yeah, so I'm gonna put back those wires I had on there so that I can take a look if this actually works now. Like, I hope it did. I didn't actually desolder these because they just fell off, but that's what you get when you solder them just like that. Alright, and this time I'm on the other side of the resistor, so I don't need to poke around with any probes. Here is my ultra dodgy setup to check this thing. This one clips on here. On the bottom side there's some exposed, how do you call it? Anyway, this is connected to one side of the mains that goes to the same net as the top part of that connector. That clip grips onto one of the pins, and I hope it doesn't touch the other. And then we have this connector that just happens to be the right size to bridge these two. This is only for a quick test anyway. And then I make sure that the other side of that is well out of the way. Don't want to get zapped by that. And then for two wires they go these clips, and then I got another multimeter. I'll turn that on, and we'll first power it up normally, and then I will connect over here also a cable that goes to the same one as this, and we'll see if that makes a difference. It did not. I measured like 2.5 volts either way, changing a tiny bit, but they'd set this up so that it changed properly, like actually go from 0 to 3 or something like that. It just doesn't make sense to do it otherwise. So let's see. And I have this hooked up to a isolation transformer, but not necessarily because I want isolation, but I can turn up the voltage a little bit slowly here, so that if something is shorted, I'll know, and then nothing bad happens immediately. So go to 200 something volts. I'm expecting to hear click from this board. So it did that before, and I hear a spark. That's not good. I figured it out, the black wire wasn't making proper connection, it's kind of touchy. So now if I give it some beans, we got 1 volt and it says click, and click again. I don't know if 1 volt is what we want to see, but it's different than before, so I'll take it. Now power down again, and take another wire. And like, if you decide to do this yourself, please be more careful. Something. And now we got 0 volts. So 0 or 1 volt when it's on or off. I don't know if that's what it's supposed to be, but let's hope so. Now alcohol to clean up flux, and the Sharpie marks. Already cleaned up the solder where I had the wires attached, and if all went well, the next scene you'll see is a running washing machine. Almost forgot, this is the new one, and it is indeed 4.7K approximately. Seems kinda strange, there's 1 volt on that pin and not a sensible logic level like 3 volts, but I suspect that the voltage looks actually like the simulation predicts, and the multimeter just makes 1 volt from that, and it's going actually like between 0 and 3 or something. And we don't need to get out the oscilloscope, not worth our time. We're just gonna throw it back in the washing machine and see what it does. My bets are on it being repaired, since we now have a difference between having the heater on and off, which we did not have before. So that didn't do it. We still have the same error. And I'm wondering, did I break that resistor by soldering a wire to it? I've never had that happen, but who knows. And the next thing that happens is that my friend calls AEG technical support. They send over a guy from Electrolux, and that guy goes and looks at the thing, sees E6A, he says we need to upgrade the firmware on the main board, and after doing so the machine comes back to life, washes the clothes happily, and he tells my friend that this is a problem they've seen before many times, and it took them a long time to figure out. But it only happens in the city of Ghent in Belgium because of some signal we have on the mains power for the meters or whatever, and that's why with the older firmware that machine gives you that error. Yeah, weird, really weird. Yeah, if anyone knows more about that, leave it in the comments down below. Yeah, and until then, cheers, thank you for watching, and goodbye. In case anyone's concerned, I'm not just sweating and drinking because like I've been defeated. It's really hot today.